All set.
Sounds good. How often do you think about your personal water consumption?
Well, now I can't help but think about it all the time because I teach it, right?
Hmm.
So at the same time that I'm teaching in class about water conservation in Tucson, by the way, you can't help but be thinking about our own use on my lawn or something like that. But one thing I do actually, I use my own uh, behavior, my own interaction with the utility. Here we're getting our water from Boulder. I used to be with a left-hand uh, water district. And I use examples from that, like the shape of the bill, how they organize the bill so that we pay more the more we use, things like that. So I'm even using some of my experience as in water education.
Awesome. Um, what do you believe is a type of water usage that is underlooked in the day-to-day life?
Well, boy, that's a really good question. And do you mean the a water use that um, we might think of as less than important, or that could be more conservation oriented, or just one that we're not thinking about?
I would say more like one we're not thinking about.
Yeah. So, there's a lot of different ways of analyzing this and thinking about this. And one of them is the water that's already, in a way, consumed to make products that we're using. And that is a common, none of us really know, say, the carbon input required for the computer screens that we're looking at, or something like that. We might have a good sense of our carbon footprint from driving or heating our homes or something, but the carbon. So I'm using carbon as an example. So the same is true with water, right? You just you're not really going to consider the water in the cucumbers that were grown down in the lower Colorado Basin when you have a salad. I may some do, by the way. Let's just say that many people do, but I think maybe one thing that you're getting at is how conscious are people of their water footprint, and the water that shows up in our footprint and doesn't look like or seem like water to us. We're not bathing in it. We're not watering our lawns in it. We're not drinking it. We're not washing the dog in it. That's the water that we don't see.
Hmm. So would you say more diet water, water used to create food?
I don't know for sure, and I've seen some of the numbers, right, of the many things that you and I are using, even the computer chips, in these computers are use some water in their manufacturing,
Hmm.
and create water quality problems. So I have to honestly say I don't know, but if I had to guess, I would say that the average American household, when it's using these um, what's it called? Not imbued water, but the water that is baked into manufactured items.
Ooh, I'm not sure about that one.
Yeah, we have to look that up. But I believe that I think we recognize that food has used water, irrigated crops, and water for livestock production, but we probably underestimate the water that's in manufactured goods of all sorts. Even if it's just the water that's used to clean the parts of a manufactured, like computer parts.
Hmm. That's very true. Because I mean, when I was doing this project, I was thinking about water usage in food a decent amount. Honestly, I
Sure.
never really thought about, I know steel uses a ton of water, and I just never really thought about that as well.
Yeah, and I don't see as much data about that. I think we can really pretty easily look up our water footprint for food and a couple of other consumer items, but there's an awful lot of water in other aspects. Still, especially out here in the West, uh, we know one simple fact. Most of the water that is put to some use, meaning it's taken out of water bodies, out of streams, out of lakes, out of reservoirs, out of the ground, and put to some economic use, is actually in agriculture. So we know that to be true. And so, yes, indeed, food and related products easily come to mind as having this imbued water.
Let's see here. Next question is, what can people, how can people manage land to conserve water?
Well, and this really asks, it's a big question that needs to be broken down. What kind of land are we talking? Are we talking about, land that we go hiking on, or land that we own, or our front yards, or a cornfield?
I would go a more personal, traditional home type of land, like some land that we own.
Yeah, and this is pretty easy now in the West. We really need to move away from watering lawns and green spaces. And not totally, even the more, I think, successful and serious-minded efforts to reduce outdoor watering in, say, places like Las Vegas and all, have recognized that what's called functional lawn can be an important part of family life. So that the kids can kick a soccer ball and be ready to, to go to their soccer games. But the relationship between functional lawn that's actually used in creating economic value or recreation or aesthetic value is almost certainly in most studies smaller than the amount of lawns that we have. So that's the first one, right? Um, the other one is that we could collect water, rainwater, or make better use of rainwater. And many people who water landscapes all over the West actually do this. They don't even know they're doing it when they aerate their lawns. It's a process that often a homeowner does to poke holes in it. They're actually improving the infiltration of rainwater onto the lawn and reducing the stormwater runoff. And you see this also in some rainwater-oriented landscapes, including some on our campus that are meant to allow infiltration. And thinking about that, you have to actually plan it though, right? If you don't make the land that we live on here in the West try to increase its infiltration rates, it causes a lot of runoff. In a heavy rainstorm, most of that water is running off.
Mhm.
But if you treat the land in a certain way, with uh, uh, some sort of infiltration process, even soil amendments, it can not only absorb but hold the water better, and you get a lot of benefits from that.
Awesome.
We
Uh,
also could think about the water that's running off our roofs.
and then that just goes straight to the gutter for most
Yeah,
places. Yeah.
and there's recent legislation in Colorado that makes it legal within the water rights system. This is true across parts of the West, but not everywhere yet. And to collect that water and use it. So I just got a rain barrel this summer, and you put it on your downspout, and even a small roof of just like a small house or just your duplex in a heavy rainstorm produces a fair amount of runoff. And can fill a barrel that you can then use for various things. I mean, you can wash the dog in it, right? The kids can play in it, but mostly you would use it then for watering landscape.
If you don't mind me asking, what do you usually use your water collection barrel for?
For the grass that's near it. I have some grass that hasn't been taken out yet. I like having a bit of grass, and we use it. Maybe half of it's functional, half of it is what Denver Water might call non-functional, or Las Vegas Nevada Water Authority might think of as non-functional lawn, meaning lawn that we don't make much use of. But it's really neat to be able to put some water on it that I didn't have to buy from the city.
Yeah. What effects do water quality and quantity have on wildlife habitats, aquatic systems in our area, in aquatic systems in our area?
All right, and let's turn that question around a little bit. That I think we just have to recognize that water is part of ecosystems, right? And not only aquatic species. fish and invertebrates and others, but a whole bunch of terrestrial species rely on surface water and a little bit of groundwater as part of the ecosystem. So the real challenge there has been where we've extracted that water from the ecosystem. And one thing we do in the water class, of course, is we try to analyze where are we taking water and what's happening to the natural water features, streams and lakes, including especially how have you changed the pattern of water? And one thing that humans have especially done in water systems across the West is maybe when there's heavy snow melt and rainy periods, the streams are full. But when they come down to their low point in the year, their average low point, often in late summer, those low points, those low flow times have become lower and lower, such that we have more and more streams that actually get dewatered for a period of the year, so that the stream bed is actually bare to the air, right? And this means that even invertebrates that are living there have a struggle to get through that period, and lengthening that period or causing a stream that always had some water in it, even in the low flow, to a stream that at low flow was carrying no water, or a segment that had no water, uh, is a big ecological change. I mean, just that, it's just the difference between day and night. The other point that you asked about was quality. And as volume declines, quality also often declines because not only human-induced pollutants, but natural concentrations of chemicals, minerals that become more concentrated can be difficult for wildlife to manage as well. So if we lower the volume, even in water that is we might think of as pristine, we're still concentrating some of the dissolved salts and other minerals in that remaining volume, and that can make it make it more toxic.
And then you were mentioning about the dewaterification of streams in the late summer. Would you say that's due to water usage and climate change?
Yeah, I think that the climate change question is really a big one, right? And we could spend we do in class, right? We spend a lot of time on it. Right now, there's good evidence that a warmer climate that we are experiencing here in the American West, but globally, does probably cause some parts of the of basins to become drier because not because it necessarily rained less or there was less snowpack, but because evapotranspiration demand was higher. So there was more evaporation, more evapotranspiration. So I think that as we tie that directly to how much water is available, that's one small impact that is growing, still relatively small. The big impact is our use.
Mhm.
We need the water, right? So here we are on the Front Range, where most of largest populations of Coloradans live. And it so happens that the west side of the divide is wetter than the Front Range, naturally, right? So this is why there are tunnels and ditches and other infrastructure that moves water from the west side of the divide to the east side, because you need the water to, well, if you develop water in order to serve populations, and the populations are bigger here. And that has caused then reduce the stream flows on the west slope. In an odd way, in some places on here on the Front Range, it's actually increased the stream flows, as you
Really?
might imagine. And partly because of, especially when it's water use for urban uses, or what's roughly called municipal and industrial use. Um, uh, Much of that M&I water actually makes its way back into the streams. And unless you put it on your lawn, most of the water that you take a shower with ends up back here in Boulder, most of that water ends up back in Boulder Creek after it's been treated out at the 75th Street sewage treatment plant. And it's back in the creek. Now, the water that you might use outdoors to water a lawn wash your car. Little of that makes it back in the creek, but a lot of municipal and industrial use, inside use, uh, actually makes it back into the creek. So if we move that water from the west slope to the east slope, in a few places, we're actually adding some water to the creeks. And the question gets to be, how well are we treating it? So what's its quality?
That's really interesting. I had no clue about the increased water in the eastern Colorado.
Just in a few, yeah. In fact, you could probably see this number if you looked over the years at the South Platte. Uh, there are times when the South Platte a lot of what it's carrying, the water it has already been used once or more than once, and is back in the river. Now that might mean there are places where it's thinner because it gets taken out and is used, and then it's put back in somewhere else. This is a pretty common pattern in the West, well, really around the world, and so we may still actually be reducing the flow in some segments, and that's tough on that ecology. But in this case, in this particular case, we've caused a net transfer of water from the west slope to the east slope. By the way, not only is that a hydrology thing and a water use thing and an ecology thing, but it's also a political thing. And it
What are you
has,
talking?
in the sense of causing some tension between the west slope and the east slope of Colorado. And this even shows up, for instance, the Colorado Water Plan, which has been revised recently. I think it was first put together in 2015, was built on regional groups called roundtables. And one concern that got raised over and over again by the roundtables on the west side of the divide was this very problem or this problem issue, transmontane diversions. So we moved the water through the Adams Tunnel, through the Moffat Tunnel and others, and we brought it over to where the population was and where there was more agricultural land. And the concern raised in the Colorado Water Plan is especially you need to quit doing that because we need the water on this side for our well-being, for our development, and for our ecology.
And then this one is going to be a loaded one, but where'd it go? Oh, there it is. If you could change government policy directly relating to water, what would you change?
Yeah, it's a great question. I think a pretty common answer. I'm not certain it's my answer, but let me be academic here for a minute, right? A pretty common answer would be to think about changes in the water rights system. If you can find where the water rights system is causing inefficient water use, then you can find efficiencies. I think that there's some room for improving the water rights system. It's a bit old-fashioned, but it probably isn't quite the problem that some water analysts think. In our part of the world, a really significant policy change, it's actually sort of underway, would be in the big basins, like the Colorado River in particular, would be the sharing and the way that drought or dry years are managed, and how the users, the different users, contribute to trying to keep that basin healthy in the driest years. And that's been a problem, especially in the Colorado, but it's also true in the South Platte. It's true down in the Arkansas. It's true in the Rio Grande. And it's the dry years that really cause both ecological, social, and economic impacts. And the policies aren't sensitive to that. They make an allocation, right? The upper basin states get this much on average, and the lower basin states gets this much, and Mexico gets this much, and it's fixed. Whereas we go in and out of these 3, 4, 5 dry years, and then 3, 4, 5 wet years. If the policy could be more flexible, if it would encourage the different users to, for instance, as we come into a second or third dry year, it would be, and this is a good plan that's been implemented in a few places, if some of the bigger users, like say an irrigation project, would fallow their project for a year or two. But in fallowing, they would not lose the right to that water. So you have to change some of the contracts that allocate water to users to help them actually respond better to natural variation. And I think that that's probably the anachronism of water policy. It's not as flexible as our climate demands.
Yeah.
And so that's where the push comes to shove. And that's also when species get hurt during the dry periods. And if you're a rights holder, you actually need protection to decide not to use your water. You actually need a guarantee from the state engineer or from a legal framework that if you were to donate your water, for instance, to keeping it in the stream during a period of time, that you wouldn't lose access to it when the drought cycle comes back. And that I think that would be that would be a help, I think.
The use it or lose it law.
Well, yeah,
Or
and use it or
routing.
lose it is not quite as obvious as that. It's an easy phrase. We all use it. I teach it in class. Uh, it's a big deal for someone to claim that another water rights holder has abandoned their water, and using less of it for a short period of time shouldn't trip that sort of vulnerability. And mostly in the current appropriations, it doesn't. But what if we wanted it to be a regular process so that some users would be ready to say take take a payment rather than the water? And
So,
that's one way that we can, and this is one of the, so we got one more thing here, and that is these mechanisms that work their way through water rights to allow for in-stream flows. And so we need better legal mechanisms for keeping water in streams while also respecting water rights.
let's see. Um, let's see. I got one more question for you, if that's okay.
Okay.
How do you believe climate change will impact the water and snowmelt supplies collection in the West?
Yeah, it's a great question. It's a big problem. We already know a few things. We've already warmed up in the West. We haven't, parts of the Southwest have gotten drier, especially in certain seasons. But the warming, I think, is the most obvious signal that we've already experienced, not just projecting into the future, right? We've already experienced it. Since I've been teaching here for 40 years, we've seen um, earlier snowmelt, not necessarily always smaller snowpacks, but earlier snowmelt. And this is a problem for water management in lots of different ways. And also, a given amount of snowpack that you go up and they measure the snowpack, right? The Natural Resources Conservation Service and other people, they'll ski up into the mountains or they have these satellite remote sites that tell you what the snowpack is. And everyone follows how much snowpack is there. Not just the skiers, right? All the water people. And it looks like that the given amount of snowpack is not delivering as much runoff as it used to. Not only is it melting a little earlier, but it may also be evaporating more in the warmer climate. So we have earlier peak in flows, and that is a problem for supply management and reservoir management, especially if the earlier peak, like in California, happens to coincide with the flood season, when reservoir managers are required to keep their reservoir partly empty to absorb flood flows that could come along any minute, in any heavy rain event like the one they're having right now in California. So just that warming. Then the big question for the future is how does that accelerate? Does the warming accelerate? Does it then continue to move the melt, say another month earlier in the season? I mean, we peak here in the Front Range, what, in June or something? I mean, golly, can you imagine, the second half of this century, our peak snowmelt is occurring in April, which right now is when we come toward our peak snowpack, not snow melt. And that changes the ecology, it changes the management, and that can be mostly from warming. The big unknown, just to answer your question, then, is the climate science available today struggles a lot to project what precipitation of the future will be. So I have my class do 50-year projections from the current set of climate models that are available. They're well known. They're used around the world as part of the Intergovernmental Panel on Climate Change, the UN Framework Convention on Climate Change. We're using the same models, and we run them for the upper South Platte, or we run them for the Strawberry Reservoir in Utah. And the temperatures always warm up, and it makes good sense. And you can just get a clear signal, and that signal is already in the historical record. The precip rarely shows a strong signal. It's there, it's flat, or it gets less certain, or it becomes more variable. So the mean stays the same, but the differences from year to year get larger, and that's a problem for water users and a problem for our systems. I think we'll learn more about this. The physics suggests, and I'm not a physical climate scientist, but I try to keep up. We bring it into class, and some of the students are pretty savvy along these lines. The physics suggests that a warmer world should actually be wetter, right? The hydrologic cycle should actually be energized in a warmer world so that we might actually see more precip in especially the mid latitudes. We don't know yet. And if it does get wetter, and I can find a few places in our neck of the woods that the projections call for actually uh, uh, more rain, more snow. Uh, the variability from one year to the next also increases. Anyhow, a lot of uncertainty, but the warming and the variability make it a problem for water management.
Speaking of the variability, I feel like we've seen that a fair amount. I'm from Southern California, so we've seen that a fair amount there where we go years with like 25% of the average rain, and then last 2 years we've had 200%. It's just crazy switches within the.
Oh, yes. They're even calling it climate whiplash. And it's actually been around for a long time, especially in the West Coast and in the Sierra Nevada. How the dry years and the wet years and the dry years. I think it might be becoming a more intense pattern. And the other point that you would make as a Californian is that the elevation at which, say, January precipitation falls as snow versus rain is changing. And this is actually well documented too. So you drive up from Sacramento up towards Donner Pass, and there's an elevation. I don't know actually what it is. Maybe it's 3,000 feet or something like that, which is the average 32-degree temperature surface. Now, of course, it moves up and down every day and every night, but that's the average location. And people who live above that know that when January comes around and there's a storm, it's going to be snow. And then people who live below that generally expect it to be rain. But that elevation is creeping up in a warmer world. And so that's one of the more strong signals in the West that Sierra snowpack in particular is shrinking, partly because of that, not because there's less precip, but there's a transition to more rain than snow.
That's very interesting.
Yeah,
Awesome, man.
where have you been? Where do you hang out in California?
California, do you know Ventura County?
And sure, this will be on the coast.
Yeah, it's the county north of LA County.
Yeah. And so if you drive the coastal range and then you go over, what would be the first range to your west, that has snow on it? The San Bernardinos? No, something north of them.
San Gabriel's get snow occasionally.
Yeah, right. And almost certainly there's a place that has some snow that will get less snow in the future and more rain.
Hmm.
in a warmer climate. But boy, you make a really good point about these swings. And that's kind of always been true. You get 4 days of heavy rain when an atmospheric river, what we
Yeah.
used to call the Pineapple Express, comes along. And then it's dry and sunny after that, right?
Yeah.
And every once in a while, California goes through multi-years. 2015 started a multi-year drought. Another one in 2021, I guess, in which the governor declares a state of emergency, has a press conference at some place that would normally have 3 or 4 feet of snow and it's bare, in December. And then the next year, that place has 6 feet of snow.
Yeah. It's crazy the last few years, the variety within the precipitation totals.
Yeah. Yeah, it'd be an exciting place to be a water manager, right? And to be a hydrologist and a climatologist. I hope that that's what you're going to do, Jake.